Okay, so when you went to use the quadratic formula for number 2, you should have your a value as 4 and your b value is 0 because there is no linear term. There is no x term, so the b would be 0, and then your constant is negative 16, so your c is negative 16. So then you substitute into the quadratic formula. So negative b would be negative 0, which is 0. And then plus or minus our square root of b squared minus 4ac. So that would be 0 squared minus 4 times our 4 for a times our c of negative 16. And that's all over 2 times a, which would be 4 in this case. So then when you simplify, you end up here in the square root having negative 16 times negative 16, which is positive 256. And that's over 2 times 4, which would be 8. So we would simplify that to be, so 0 plus or minus the square root of 256 would just be plus or minus the square root of 256 over 8. And the square root of 256 is 16. So we have a plus or minus 16 over 8. So that means it would be a positive 16 over 8 and a minus 16 over 8. So our two answers for our x equals would be x equals 2 and negative 2 when you simplify that. Okay, the last part for tonight's video is talking about our graph. When we see our graph and it's not a real solution, we can use our quadratic formula to find out what's happening. So I want you to go ahead and try one more use of the quadratic formula. Use this equation, substitute into that quadratic formula, and see what you get. So when you do that, you get our a is 1, our b is 4, and c is 5. You subset into the quadratic formula, and you have negative 4 plus or minus the square root of 16 minus 20 all over 2. Now 16 minus 20, remember, is negative 4. Now think back to the beginning of our unit. Remember what the square root of negative 4 means. Remember, we can break that into square root of negative 1 times the square root of 4. Remember, the square root of 4 is 2. And remember our definition for the square root of negative 1. That's our imaginary number. So we would have an imaginary number here of 2i. So let's see how that looks in our formula here. So if I have a negative 4 plus or minus, and we've simplified that square root of negative 4 to 2i all over 2. Now we can see we can also all have a factor of 2. We can factor that out and simplify that 2 divided by 2. So that would equal, if the 2's cancel, that's equal to negative 2 plus or minus I. So it would be negative 2 plus I and negative 2 minus I. You can leave them written like this when it turns out to be too imaginary. And going back to the beginning of our video, let's go ahead and add some more information here to our graphs. So now we know that these two are two real solutions, and we have one real solution when it lands on the x, the vertex is on the x-axis, so it's one real solution. And now we know these are non-real solutions, and they would be two imaginary solutions, two non-real solutions. So these are imaginary solutions. So if we go back to where we were in our notes here, on the bottom of this page, we have a vocabulary word called the discriminant. And the discriminant is the part that's under the square root in the quadratic formula. So the discriminant is equal to b squared minus 4ac. And if you think about what we just found out, This number under here is going to tell us what kind of solutions we have. If it's a positive, like our first two examples, we would have two real solutions because you'd have a real plus or minus another real divided by a real number. So that would be two real solutions. Now, if it was like the one we just did and it became a negative under the square root, then you would have two imaginary solutions. Lastly, if our b squared minus 4ac became a 0, we would just have one real solution because you'd have a negative b plus or minus 0 over 2a. So you wouldn't be adding and subtracting anything. So there's only one real solution, and that would be an example of when the vertex is on the x-axis. So this vocabulary word discriminant, again, is the b squared minus 4ac, and when we find that number, it will tell us the kind of solutions we have. That's all for tonight. I hope you have a great night. We'll see you in class.